Okay everyone, for this presentation you'll need the same items that you used last time. You'll also need to have available GSS 2008 subset. After all, that's what we'll be looking at up front. Notice this problem asks us to determine for the age of respondent, determine the probability of having someone with an age of greater than or equal to 60. Since we're talking about age of respondent from the GSS subset, obviously we need to find two things for age of respondent. Remember, we go back to our Z-scores, what the formula is. What we already know is what the score is we're looking at, so we need mean and a standard deviation to complete that process. So let's go to the GSS data. Here we go. And for age of respondent, now question number B asks us for education, so I'll tell you what, I'll just do both of them at the same time. Descriptives, frequencies, nothing new here. Where is age of respondent? Respondent's age is here, age of respondent, and as I said, I'm going to do education at the same time. There we go. And the statistics we need are mean and standard deviation, and I haven't explained this yet, but I'm going to select standard error of the mean as well, and I'll illustrate and I'll tell you why in a little bit. Continue. Again, we're not doing anything new, so I'm doing this pretty quickly. And so here is the table that gives you the information that we need. So just to be sure, for age of respondent, the mean is 47.71 and the standard deviation is 17.351. Okay, so given that, we could go back and compute the Z-score. Right, Z is equal to 60. That's the score we're looking at. 60 minus 47.71, all right, divided by the standard deviation, which is 17.351. So we end up with, and I need my calculator, give me a minute to do this, you could be doing this as well. 60 minus 47.71 divided by 17.351, and that will give us a Z-score of 0.7083. Because Z-scores on our table are only 2 decimal places, I'm going to round that to 0.71, and so that's the Z-score we'll be looking for. Let me go back to the question, and notice the question asks us for greater than 60. So one other thing we'll have to do is we'll have to build our normal or normal curve, and the mean for our normal curve is 47.71, and we are comparing that with 60, which is our score, and so this is where 60 would be. And the question, back to the question, asks us for greater than 60, so it would be, sorry, so it would be in this area here. So to quickly go to, oops, let me, 0.71 is our Z-score, so we find 0.71 wherever that is, and we're looking for the area outside, 0.2389. So our probability would be 0.2389 or 23.9%. All right, and while we're at it, let's go to the second question, and the second is 45 years old or more. This one might be a little trickier, but let's figure it out. I am going to see if I could I'll just draw a new normal curve here. This doesn't look very good, but hey. So this is 47.71, and at this time we're looking for 45, which would be over here somewhere. All right, 45. So this time we're being asked to look at 45 or greater, which is here, but it's also over here, right? Because over here would be greater than 45. So it's this plus this. So or this area plus this area. So let's figure out how we would do that. Again, our z-score would be 45 minus 47.71 all divided by 17.351, and that would give us a z-score of, again we are looking at the absolute values, and here we end up with a z-score of 0.16. Let me do that calculation one more time. 45 minus 47.71 divided by 17.351. This is a minus number, but again we're looking at the absolute values. So in this case we have to look at the area between, which when we go to for point, what is it, 0.17? 0.16. So if we go to 0.16, the area between is the second term is 0.0636. So the probability, probability equals 0.0636 plus 0.5000 to give us 0.5636. Alrighty then. And the question you're asking, why am I adding that 0.50? Because everything on the right of the mean is 0.50. And so we were looking at this piece plus this piece. So in that case, we have to add a 0.500. So then, let me conclude by making a couple, and you could run the others yourself and see what answers you get. Just a couple concluding points here with respect to finding the probabilities, and you could do for education as well. There is no algorithm for determining if something is greater than, then you look in one column, or if it's less than, you look in the other column. You actually have to go ahead and build your normal curve and use the normal curve to figure out what you're looking for. Are you looking for the area outside? Are you looking for the area in between? Are you looking for a combination? Well, you really do have to build your normal curve, read the question, figure out what areas you're looking for, and then build your probabilities based on that. Okay, so then this is kind of like a shorter presentation. We're done here, so go ahead and take a couple minutes and run through these exercises again, check and double check, and do the exercise on education as well for your own edification.